Hello everyone. In this lesson, we will work with derivatives of e involving the quotient rule, and we also work with the application of the derivative of transcendental function. And in this lesson, we will find the relative extreme point of certain functions. So let's start with this question number 1. I have y equal to x squared minus 3, the whole thing divided by e raised to exponent 3x. As you can see that obviously we cannot simplify this term any further. Therefore, we just have to differentiate this exact function. So in this case, I will apply the quotient rule because I have one function divided by the other function. So the quotient rule said this: if I have a derivative of u divided by v as a function of x, then the very first term is v times du over dx subtract u times dv over dx, the whole thing divided by v squared. So this is the formula for quotient rule. So in this case, I am going to identify u as x squared minus 3. Immediately after, I will take derivative of u as a function of x. So du over dx will be equal to 2x minus 0. So I don't need to write the 0 in this case. So v will be equal to e raised to exponent 3x. So derivative of v as a function of x will be equal to the exact same thing again, because we are working with derivative of e. Then multiply by derivative of the exponent of e. In this case, it will be equal to 3. So all you have to do is next is just substitute all you found into this equation right here, and then we simplify our answer and express as positive exponent. Alright, okay. So dy over dx will be equal to v, which is e to the 3x. Okay, multiply by du over dx, so I multiply by 2x. I subtract this with the u, so I multiply x squared minus 3 with the e to the 3x times 3. Okay, the whole thing divided by v squared. So v squared is e to the 3x, all of it raised to the exponent 2. Alright, okay. So let's simplify this answer. Simplifying this answer, you can see that you have the 3x here as your common term. So I will pull out the e to the exponent 3x. Inside the bracket, I left with 2x of the first term. The second term, I will left with 3 times x squared minus 3 in the bracket, and close the bracket. And in this case, I should have e to the 3x raised to the exponent 2. Alright, so I should write it here for everyone that e to the exponent 3x is in fact e to the exponent 6x. Okay, so just to remind everyone that if you have a raised to exponent n, all of it to the exponent n, so you have to multiply the two exponents. So how do we simplify this any further? So in this case, you can see that this and this cancel. So in this case, you should have e to the exponent 3x left. Okay, so I will have 2x minus 3x squared plus 9 if you want to multiply them out, and the bottom as a denominator will be e to the exponent 3x as the final answer. Alright, okay, so let's continue with the next lesson. The next question. So this is one of the application. Okay, determine the relative minimum points of the following function. So I have this function y equal to e to the 3x plus 12 times e to the negative x. So in order for you to find a minimum or the maximum point or the extreme point of a function, you have to differentiate and you let the derivative equal to 0. So at your maximum and minimum point, if you draw a slope through that, the line tangent to that point will be a straight line, okay? The straight line, and it's a horizontal line. So if you have a maximum point, so let's say your function is like that, right here, maybe your relative max or your maximum point. So if you draw a line through this, okay, the line tangent to this point will be your dy over dx, and you have to let that equal to 0. So the same thing here. So in this case, you will have dy over dx, and it's also equal to 0. So at any of the extreme point, the derivative would mean the slope of the line tangent to the curve will have to be equal to 0. Okay, excuse me. So I think I just want to correct this part here. But my whole line is gone, so let me draw that again. Okay, so in this case, if I want to draw this line through here, so that will be the extreme point, and dy over dx will have to be equal to 0. So basically, that's what we have to do in this case. Alright, okay, so we don't need to have it here, so I am going to write dy over dx equal to, so the first thing you have to do is differentiate and let this equal to 0. Okay, so dy over dx, so derivative of e to the exponent 3x will be just e to the 3x times 3. Okay, and I add this with 12 times e to the negative x. The exact same thing again, I multiply by derivative of negative x, so in this case is negative 1. So dy over dx equal to 3 times e to the 3x subtract 12 e to the negative x. Okay, so I want to make a note here is relative minimum point occurs at dy over dx equal to 0. So I am going to let this whole thing equal to 0, and from here they ask me to find the minimum point. It means that you need to find the x and the y. Okay, so you have to find the coordinate x and y. So since you let this equal to 0, you can easily solve for x. So solving for x, I am going to bring negative 12 over to this side of the equation. So I will have 12 e to the negative x equal to 3 e to the 3x. Okay, we should simplify both sides of this equation. So I will divide both sides by 3. Okay, now I divide both sides by 3. So dividing both sides by 3, I will have this side equal to 4 times e to the negative x equal to e to the 3x. Okay, so in order for me to solve for this, again, I will do one more step by I will take this divided by e to the negative x on both sides of the equation. So I'm doing this so that I can isolate the e. Okay, isolate the exponent, e with the exponent. So in this case, you are having that cancel with that. Therefore, I will have 4 equal to, so I want to remind everyone of these formulas. am divided by an, you are going to subtract the exponent in this case. So that means I'm going to have e to the 3x subtract negative x. So 4 equal to e raised to the exponent of 4x. Okay, so Now, the next step is how do we solve for the exponential equation? To solve for the exponential equation, what you need to do is you will take natural logarithm on both sides. So I'm going to take, let me write a note, take natural logarithm on both sides. So that's how you are solving for the exponential equation. So I will have natural logarithm of 4 equal to natural logarithm of e raised to exponent 4x. So at this point, what you want to remind yourself is a few properties of logarithm. So I want to remind everyone of this. Ln of e to the 1 is equal to 1. Okay? And why do I have this? Because ln is actually natural logarithm of the base e. Alright, so if you have the same base of the log, okay, your base is your log is the same as your base of the power, then this will cancel out and the answer is just equal to 1. So basically I am basing all of this on these formulas right here. Natural logarithm of e to the exponent n is equal to n. Alright, so all of this are property of logarithm. We should keep that in mind. So for that, I will have natural logarithm of 4 or ln of 4 will be equal to 4x. Alright, excuse me, I keep having this one zoom out. So I will have now this, according to natural logarithm property, this will turn into 4x. Okay, so now you see that you eliminate the e and the natural logarithm of 4, you can easily find that using your calculator. Alright, so if you use your calculator, you can find natural logarithm of 4 is equal to 1.386294. So I use quite a few decimal places in this case. So then x will be equal to this number divided by 4. So then x will be equal to 0.34657. Okay, so having x equal to this number, what you do is you are going to substitute x. Then your next step is to substitute x equal to 0.34657 into the original equation. Y equal to e to the 3x plus 12 times e to the negative x to find y. Okay, so therefore now I will have y equal to e times raised to the exponent 3 multiplied by this number. Add that with 12 times e raised to the negative 0.34657. So I will write each number down so everyone can just check the answer by using your calculator. Okay, so this number will become 2.8320. This number, okay, I will write e to the negative 0.34657. So to make sure that everyone used the calculator and got the correct number as well. Okay, so now it's just bad math. So I will have the answer as 11.31366. Okay, so let's double check. E to the exponent 3 times this number will be e to the exponent 1.041. So to make sure that you use your calculator and get this number, so that you know that you use the correct key on your calculator. And also use your calculator to figure out this number here so that you know that you are using the correct key and the correct process. And in the end, I want to make a conclusion here. Okay, so therefore, the relative minimum point is 0.347. I am going to round it to 3 significant digits. Okay, so 0.347, and 3 significant digits for y should be 11.3. Okay, so make a note here as 3 significant digits. Okay, all right. So I have a few questions for everyone to try. I just want to take the opportunity and remind everyone to make sure that you try this question. And let's recap what we have done. Okay. So in this lesson, we are finding derivative of e and involving the quotient rule. For e with the quotient rule, we apply this quotient rule for derivative right here. And as you know now that a quotient rule applies to derivative of transcendental function as well. Whatever function that you have, if it's in the case of one divide into the other, then we should apply the quotient rule. You can also modify to use product rule, but I don't recommend that in this case. So then finding derivative of u as a function of x, identify v is always a denominator, and find derivative of v as a function of x, substitute into the formulas, and then you simplify to find the final result. Okay, so to find the minimum point of a function, so this is a word problems right here. So we have to understand that minimum points occurs happens when the tangent to that point equal to 0. So the tangent to that point will be a horizontal line, and the derivative of a horizontal line is always equal to 0. Okay, so that's why you have to take derivative of this function, and then after that you let this dy over dx equal to 0. So because you know that the extreme point occurs at dy over dx or your derivative equal to 0, then from here you can isolate the x, going through the process, isolate the x to solve for x. So in this case, y isolating and simplifying this equation, I end up with the exponential equation in this case. To solve for exponential equation involving the e, I have to take natural logarithm on both sides. So taking natural logarithm on both sides, we have to remind ourselves of a few natural logarithm properties. So in this case, taking natural log of e, the purpose is in fact you eliminate this term. So on the right hand side of this equation, you end up with 4x. Ln of 4 is easily found by using your calculator, and you have this number, and you solve for x. After you have x, you have to substitute that into your original equation in order to find the value for y. Because obviously y equal to e to the exponent x here. So if you substitute that in, y is the unknown. And then using BEDMAS, you can easily find the relative minimum point that they ask for. Okay, so in this case, I round to 3 significant digits, and I work with quite a few decimal places. I also want everyone to remind yourself of the process of how to key this into your calculator with the function e and with the negative number as exponent of e to get the correct answer. Alright, thank you.